back. Our first session today is Virtually Better, the Science and Practice of Therapeutic Virtual Reality. An interview of Dr. Brennan Spiegel by Dr. Divya Chandra. Dr. Brennan Spiegel is the Director of Health Services and Research for Cedars-Sinai, where he directs a multidisciplinary team that investigates how digital health technologies, including wearable biosensors, smartphone applications, and virtual reality, can improve people's lives. His team developed one of the largest and most widely documented healthcare VR programs at Cedars-Sinai and helped to establish a new FDA-recognized field called medical extended reality. His virtual reality research won the 2017 Webby Awards for Technologies on the Internet, and in 2020, he published the book VRX, How Immersive Therapeutics Will Transform Medicine, which was named by Wired magazine as one of the top 8 science books of 2020. In fact, at our Medical XR Council, we actually look into that book for answers on several occasions. And interviewing Dr. Spiegel today is Dr. Divya Chandra, who is also an XRSI Medical Advisory Council member, also an anesthesiologist and neuroscientist. She applies this background to the investigation of consciousness and the support of tools for space exploration. She's currently a fellow at Atlantic Council, which champions positive paths forward that nations, economies, and societies to ensure new technologies and data empower people, increase prosperity, and secure peace. Today, we are going to bring Dr. Spiegel's interview via video, but I am fortunate to have Divya here in her avatar. We've heard from Divya on Human Rights Day before, and I'm super keen to know, Divya, as we watch this interview, what do you think we should keep in mind, and what do you want to highlight?
Thank you so much, Kavya, for that introduction. Can everybody hear me? Yeah, just somebody raise their hand. Yes. I don't want to take up much time because I think that this talk really speaks for itself. But what I want to do is to draw your attention to the very, very beautiful human connection, the healing that can actually be achieved in VR, which may seem like it's somewhat surprising how human we can actually be. And it's this very humanness, this very vulnerable, this very poignant vulnerability that you will see that makes it so important to protect humans, to protect our patients, to protect all the participants in VR. And Dr. Spiegel and I will talk a little bit about that at the end of his talk. So I hope you enjoy. Thank you.
Thank you, Divya, for being here. All right, so with that said, let's watch this remarkable interview, which I also had the opportunity to observe as it was taking place. And there are some moments that tell you how impactful this technology is, just like Divya said. So let's watch this video.
Welcome to Metaverse Safety Week, Day 4, focused on medical XR and healthcare. My name is Dr. Divya Chandra, and I'm a practicing anesthesiologist, neuroscientist, and medical advisor to the Extended Reality Safety Initiative. It is my pleasure to introduce today's keynote speaker, Dr. Brennan Spiegel. Dr. Spiegel is Director of Health Services Research for Cedars-Sinai, where he directs a multidisciplinary team which investigates how digital health technologies, including wearable biosensors, smartphone applications, and virtual reality can improve people's lives. His team developed one of the largest and most widely documented healthcare VR programs at Cedars-Sinai and helped to establish a new FDA-recognized field called medical extended reality, or MXR for short. Dr. Spiegel has published numerous books for medical and lay audiences and authored over 260 peer-reviewed articles. His digital health research is funded by the NIH, PCORI, and the California Initiative to Advance Precision Medicine. Today, he will be talking about how immersive therapeutics will transform medicine, also the subject of his book, VRX, published in 2020. Welcome, Dr. Spiegel.
Well, it's a pleasure to be here and to share with you some insights today about the medical applications of extended reality. And my goal is to provide an overview of how XR is being used in healthcare And then that may be able to launch some discussions about privacy and cybersecurity regarding the vulnerable patients and their data that's being transmitted through what we'll soon have as the metaverse. I want to start with an image of one of our patients using virtual reality at Cedars-Sinai Medical Center, where I work in Los Angeles. And this picture to me is striking because this woman, who's allowed us to show her image, has been experiencing pain, and traditional therapies have not been highly effective for her. And at this moment, she's contemplating whether to use a VR headset to help manage her pain. And I'll talk more about our experiences using VR. We've now treated over 3,000 patients at Cedars-Sinai here in LA using virtual reality. And this work has now led to a larger branch of medicine that we call medical extended reality, or MXR. Now, most people here, of course, are quite familiar with virtual reality and reality, or MXR. Now, most people here, of course, are quite familiar with virtual reality. And when most people think of VR, they typically think of it as a gaming platform. You know, they think of kids playing first-person shooter games, maybe. But what I'm here to discuss is a rather serious application of VR, not necessarily for gaming or entertainment, but to support human health and well-being. Now, we know, of course, that about this time last year, Zuckerberg made his big announcement that Facebook was changing its name to Meta. And this reflected the emerging importance of the metaverse. It's about 10,000 programmers now in Europe creating what will become one of the metaverses, at least the meta version of the metaverse. And this raises lots of questions about what is this all about, and what is the relationship between the metaverse and healthcare going to be? Now, this is an interesting book that was recently published about the metaverse. I'd like to sort of highlight maybe a twist on that. Rather than calling it the metaverse, I'll be focusing today on the medverse. How can we create and cultivate some corner of this metaverse that is designed to support human health and well-being, and to do it in a protected manner so that patients' data is protected, and that we can take care of patients remotely. And I'll show you some of those examples today. Now, we've been using VR, as I said, for quite some time, and you can tell because this picture is using a rather old Samsung Gear VR headset, which is now quite outdated. Back then, we would snap the VR, snap a smartphone right into the VR headset. And what I like about this picture is at this moment, this patient who has sickle cell anemia and has allowed us to use as a photo, is actually flying over fjords in Iceland, whereas moments before he was doubled over in pain from sickle cell anemia. And you can see the emotional experience that he's having. And this is the first point that I want to make, is that emotion matters. And if you think about your most powerful memories in your life, both positive and negative, almost all of them were created around a strong emotional experience. And it turns out it's emotion that really drives memory formation, that leads to lessons learned. And so what's unique about virtual reality is that when we look at MRI scans of the brain, we can see that it's triggering the emotion centers, the insular cortex, the amygdala, and it's sort of tweaking these emotion centers in a way that allows for a lasting impression. And so that's why emotion matters so much, because we don't want people to live their whole lives in a VR headset. We want them to learn something about their mind and body in VR that they can take with them. And so in this case, this patient told us that he was no longer having pain. And I'll show you in a brief moment a video of that. This is a patient with advanced liver disease. She also has been experiencing pain, but at this moment she's on a beach in Hawaii. And you can see that she's sort of happy and she's distracted in a way. But what this is demonstrating is even though she's in the four walls of a hospital room, she's able to escape it, in this case, through using the presence of virtual reality. And escape matters. The ability to get beyond your mind and body and to almost reflect back upon yourself from outside of your body, which is really one way that psychedelics work. So we call this a cyberdelic, the ability to escape yourself. This is an example of one of the scenes that we use when we're working with virtual reality. This is software from Trip VR. I have no financial relationships with them. I just like their software. And again, this is sort of like a cyberdelic. And head-to-head studies of virtual reality versus psilocybin and other forms of psychedelics, we see very similar outcomes, in fact. And that's because it may have similar effects on the human brain that we could talk about. This is Harmon Clark, who's allowed us to show his picture and tell his story. He has inflammatory bowel disease. When he comes to the hospital, the first thing he asks for is a VR headset, and we have a VR consult service now at Cedars-Sinai. What's amazing about this is what he likes to do is to go around the earth. He says when he looks back upon the earth, it gives him a sense of awe. It gives him goosebumps. It makes him feel as if he's part of something bigger. And this is, in fact, what astronauts on the International Space Station report, this sense of awe and goosebumps and sort of empathy for self and others. And so, in fact, it's been shown that goosebumps can be generated by virtual reality. This is a study called Are You Awed Yet? How VR Gives Us Awe and Goosebumps. And in this study from Canada, they posited that VR can help make self-transcendent and transformative experiences of awe more accessible to people by flying them over their city, in this case, Vancouver, then over the Canadian Rockies, and eventually into outer space while they simultaneously measured goosebumps on their forearm with a goose cam, and able to demonstrate this cause and effect relationship between these transformative experiences and a physiologic response, which demonstrates sort of the effects, the emotional effects and physiologic effects of virtual reality when we're using it for something beyond merely gaming or entertainment. Now, I want to briefly tell a story now that brings together these three concepts of emotion and escape and awe. I'll tell a few more stories and we can break and talk. This is a story from the University of Barcelona. There's a professor there named, excuse me, Mel Slater, who has been studying virtual reality for decades. And he has a very unusual laboratory, and this is a picture of one of the rooms in that lab. And what they did is they had me sit down in that chair and kick my feet out on the table. And one of their postdocs, Ramon Oliva, is setting me up here with haptic engines on my ankles and on my wrists. And then they put a headset on my face. And the next thing I know, that room with these black curtains has turned into this beautiful living space. And this is actually me looking around this wood-paneled space with my legs on the table. And what they did next is they drew some blue lines on the table and they asked me to trace them out. And in perfect one-to-one synchrony, as I moved my legs in real reality, these legs moved in virtual reality. And I started to wonder, whose legs are those? Because they look like my legs and they move like my legs. And then they dropped some balls from the ceiling. And as each ball hit me, the vibration engine that they had attached to me vibrated at the exact same moment, as if they were actually hitting my body. And now I had full body ownership. I felt as if I was literally in that body. Now, what he did next is hard to describe in words. I'll do the best I can here. But what he did is he actually pulled me out of my body. And this is me floating up into the ceiling as the balls continue to follow me, reminding me that I still have a body. I still am a self. But I looked down and recognized that that body I had just occupied was now vacant. It was also motionless. I had died. I was having a complete and total out-of-body experience. And so I'll show it to you again because it's a lot to sort of wrap your mind around. And I realized in this process of passing that the process of dying does not need to be catastrophic. And that's an important insight. I don't want to die, but to this day, I remember this experience years ago as if it happened yesterday. And in fact, Professor Slater has studied this in a randomized controlled trial of a virtual out-of-body experience reduces fear of death. And this study is really powerful because he was able to show that with this, he can actually change people's perceptions of their own body and their own mortality. Now, what these introductory slides teach us is that VR is not just a tool for gaming and entertainment. It's a tool that can profoundly modify perception among people who are vulnerable. And if we can use it to recalibrate unhealthy perceptions, it could become a new tool to improve quality of life. And this is something that we've been doing, focusing on a variety of different pain conditions in particular and other medical conditions. So for example, in the area of pain management, it's been demonstrated that virtual reality can reduce pain clinically. And this is work from Hunter Hoffman at the University of Washington, who did studies all the way back in 2007 using functional MRI scans to demonstrate the effects of virtual reality in people who are experiencing pain. And although the details of the experiment are beyond what I have time to discuss here, what you can see in this cross-sectional image of a representative MRI scan is the sort of flames or signals from the pain experience here in the sensory cortex, where you have the sort of physical ouch part of pain, but also here in the center, in the emotion centers, in the amygdala, in the limbic system. That's the emotional component of pain. And when these patients used virtual reality in a magnet-friendly version of VR, they were able to demonstrate that both the sort of emotional and physical experiences of pain were tamped down. And this has been demonstrated clinically as well. These are two famous randomized control trials. On the left, University of Washington. These are patients with burn injuries who are going through a dressing change, which is extremely painful. And on the right, women at the University of Michigan going through childbirth. And in both cases, they're randomized to VR or no VR. And on the left, the VR is the black bar. And on the right, the VR is the white bar. And what you can see here is not only did it reduce the sensory component of pain, the worst pain intensity, but also the cognitive experience and the affective experience. How unpleasant was the pain rated? How much time did you spend thinking about the pain? In both studies, they use the same outcomes. And there's this curious outcome of fun, demonstrating that actually the kind of gaming experience of being in VR can be fun for people who are going through dressing changes. So this demonstrates what we see in the functional MRI scans, that we can reduce both physical experience and emotional cognitive experiences of pain. Now, what we've been doing is going a step further and collecting some biodata off of the headset. This is a special headset created by HP called the Omnicept that measures heart rate variability, pupil diameter, and it estimates something called the cognitive load. And this is an example of me in a VR headset. And you're seeing this sort of unitless measure called the cognitive load, which is integrating all of those different biometrics into a single measurement. And I'm starting to meditate, and you can see how quickly when I meditate, I change my nervous system. And then my colleague interrupts me, and right away it comes back again, and back and forth. That's what's happening. Now, I'm showing that to you because I'm now going to show you a brief video of a patient of ours with irritable bowel syndrome, or IBS, using virtual reality for the first time. When she came to us, she had severe pain and anxiety. Treatments had not really been working. And so she said she really likes the beach. We put her on a beach, and there's a mandala that expands and contracts, and she is pacing her breathing along with it. And on the left, we are simultaneously measuring her biodata right off the headset. And as I said, when she first came in, she was anxious and upset. Almost immediately, you can see it's as if she was hypnotized after starting the virtual reality. And right about here, she said she was in heaven with her tragically deceased son, and she started to cry. And we said, "Are you okay? Do you want to stay in?" She said, "Absolutely." And right about here, she said she was with God. And she also said that she no longer had pain. And the key here is to have a conversation with people at this moment. What is going on in your brain that you don't have pain? We haven't cured your chronic pain today, but what's going on that you accessed this superpower? And I call it a supernatural power because it's natural. We didn't do anything like inject a medication. She did this herself. It was supernatural because she didn't realize she had access to this capability. And so what we talk about with our patients is that the brain is a shape-shifting organ. Like any other organ in the body, we have neuroplasticity. We have the ability to change the form and function of our brain. And this is important because some people have inherited a body that is betraying them. And we can't always fix the body, but we can change the way that we experience the body. So even if our body betrays us, we can still alter how our brain perceives our body. That's the basis of cognitive behavioral therapy, and it's the basis of what we're doing with virtual reality as well. And so I'll end just by telling a couple of stories at Cedars-Sinai. We're the largest hospital in the Western, United States. And here we've been using virtual reality for many years. We have a VR consult service. This is Dr. Omer Liron, who has created a cart that we use. We have HIPAA compliant hardware and software that collects the data, and then we can actually punch the data straight into our electronic health record and provide reports to the physicians about what the patients are experiencing. And I will now just show you a brief video that we just recently created of 2 of our patients at Cedars-Sinai using virtual reality for the first time. They're using a program called Nature VR that we created at Cedars-Sinai, and the music that you'll hear is the music that they're listening to as they go through these beautiful nature scenes. That's all right. No apologies. Yeah, we see that a lot actually. A lot of people that get emotional. Right.
I don't even have the words to explain it. It's beautiful. It's touching that you guys are doing something that's so great. Being in here and being able to just escape what's going on. And yeah, just when I'm like, ooh, I could just sit here, especially on the lake. I'm like, sure, I can pretend like I got some barbecue. That's all I need. And just chill there all day.
So that gives you a sense of what the patients are experiencing. And the question then is, can we reproduce this beyond just an individual patient or patients? And this is a randomized controlled trial that we conducted using virtual reality in the hospital, where they are separated out between using VR versus watching a television screen, two-dimensional screen, with health and wellness programming. And what we found in this study is that there was a larger reduction in the mean pain scores over the course of their hospital stay in the VR group compared to the group that watched on a television screen. And in particular, those with the greatest amount of pain had the largest reduction in pain score compared to the TV. Now, there's also uses now of VR on the outpatient side. This is an FDA cleared device called Ease VRX. Now it's called Relieve VRX. And this is an 8-week program where they controlled it against a two-dimensional experience in VR and found for chronic lower back pain, a reduction in pain scores over the course of a 56-day treatment program on the outpatient side. Now, we use this headset. We're able to collect metadata off of it for purposes of research. We use HIPAA compliant channels for that. And the FDA, of course, has been very interested in all of this and actually authorized that treatment that I showed you in the last slide. And moreover, they provided it with a special designation called a breakthrough technology. And we're now currently talking with Medicare as recently as last week about obtaining codes to reimburse the use of this, this program in particular. So there's a lot more we could talk about. I've just sort of focused a little bit today in my brief comments on pain, but there's so many other applications of virtual reality that we could talk about today. Everything from its use in schizophrenia, which is a fascinating area, to eating disorders, obesity, anorexia, autism, and the list goes on and on. If virtual reality is a therapy, then we need a VR pharmacy. We've been trying to sort of establish that pharmacy here at Cedars-Sinai. We have a virtual medicine program. This is our website. You can go to virtualmedicine.org to learn more. We have a number of different resources on here, more videos, our research, also our ongoing NIH grants. We currently have about $12 million in NIH funding to evaluate virtual reality across different conditions. Plus, we put on a conference every year called VMed, or Virtual Medicine. This has become the largest sort of medical extended reality conference in the world, as far as we can tell. And it'll be in March of this year, so you can learn more about that if you're interested. Plus, I wrote this book, VRX, How Virtual Therapeutics Will Revolutionize Medicine. I was pleased when Wired Magazine identified this as one of its top 8 science books of 2020. And really, this book, it is about VR, but it's really, what is VR teaching us about the intersection between human consciousness, philosophy of mind, psychology, technology, clinical medicine, and neuroscience. So that book is there if you're interested. And since I'm here in Hollywood, I will end with a scroll to thank all the various people that participate in our research program here. Our focus is not so much on cybersecurity or data security, but on the actual treatment protocols. But clearly, for this to be scalable and for it to be part of the metaverse, we're going to need to think about those sorts of issues. So I thank you for the opportunity to be here today. And I also have a Twitter handle if you're interested in following the latest in our virtual medicine conference does as well. So thanks very much for the opportunity to be here today with you.
Thank you, Dr. Spiegel, for this moving talk filled with patient experiences on the potential for VR to help them heal in medical settings. I'm going to start with a kind of a science question and move to some questions that are more specific to our medical XR community. I have a personal interest in this as a neuroscientist. When you consider VR as a mechanism for decreasing pain, do you believe that the neural mechanism has more to do with distraction and competing networks? Or have you measured any sort of top-down control of pain perception pathways in the brain?
Well, I think the mechanism is different for acute pain than for chronic pain. As you know well, these are essentially different conditions. Acute pain is a natural response to tissue injury. Chronic pain is a disease unto itself, where the brain itself can generate pain, so-called nociplastic pain. And so the idea is a little bit different for maybe bridging somebody through a painful experience like a spinal tap, let's say, or an IV puncture. That's, we think, just purely distraction. That's really taking the spotlight of attention from the sort of prefrontal cortex and having it focus on something else, so to speak. Whereas for chronic pain, we're really trying to achieve top-down control, trying to change the connectivity of the brain itself. Now, that is easy to say, but a little harder to prove. And in fact, we've just put in a large NIH grant, we'll see if it gets funded, with our neuroscience team to conduct serial imaging studies, starting at baseline and looking at follow-up and looking at a number of networks, the default mode network, salience networks, other types of networks that are purported to be involved in the experience of pain, both the physical and emotional cognitive experiences of pain. And just like with cognitive behavioral therapy, where some work has been done demonstrating changes in connectivity over time, we think this will be similar, but rather than needing to achieve Buddhist level monk, abilities, VR just levels the playing field. And also it doesn't require a clinician necessarily, although we still think clinicians are very important, of course. So this is something we're interested in. And we're also looking at HPA axis, or the hypothalamic pituitary adrenal axis, and cortisol, stress hormone levels, also inflammatory pathways and immune pathways, to see what is that connection between essentially mind and body, between brain and the rest of the body. And so we're going to be examining all of those factors in a recent new NIH grant that we've at least submitted, and we'll see if it gets funded. Yeah.
I mean, it's definitely a form of non-invasive neuromodulation.
That's right.
Let's talk a little bit about what people in our ecosystem might be very interested in. I found it fascinating that EaseVRX is now FDA approved. Can you walk us a little bit through this process, everything from IRB to HIPAA compliance, and perhaps what your consent process is like and where this data gets stored?
Sure, yeah. So for our NIH research projects, we are using that FDA cleared device. The device itself is a kiosk device. And this is important because it was a requirement of the FDA that the software only be housed on the hardware upon which it was tested. And so this headset cannot download, no other software can be downloaded into it, only the software that comes with it. Now, we do have the ability to pull metadata off of the headset. And so we have to inform patients that as part of the trial, their data can be collected, including how often they use the headset, how long they're using the experiences for, and even head motion as something we can capture to get a sense of how engaged the patients are. And so that's all part of the consent process. We, otherwise anonymize their data. We use, IDs that are, clinical research IDs that don't use their personal health information, so that there's a master key somewhere so that no person could interpret who the data came from unless they had the key to compare it to the known sort of second database, so to speak. So that's sort of standard practice for any research study in case there were a data breach of some sort. But I think the bigger issue here is in terms of, the scalability of this. Like if I want to download a new app on my smartphone, I don't have to buy a new smartphone every time I need a new app. I have one smartphone and I download hundreds of apps onto it. If medical extended reality is going to be scalable, we have to have a HIPAA compliant platform where I can prescribe a treatment and push it into a headset that's and in a way that's going to be HIPAA compliant. And these are concerns when we're dealing with Facebook/Meta, and of course, data privacy. We need to have a HIPAA compliant procedure and not require insurance or patients to buy a brand new headset every time they need a new, therapeutic. That's just not a scalable solution.
And that completely makes sense. I mean, have you thought about platforms that may facilitate some of that and some of the other things I'm thinking about? Because you want to do research, you want to make sense of that data and aggregate it. Are there mechanisms whereby you may develop standards for interoperability, for labeling data as it's produced, for securing that data as it's produced, so even other researchers might be able to make sense of it, or other institutions can use these systems?
Yeah, I mean, this is a huge unmet need. It's not my area of expertise, but it's definitely an unmet need. I think it's a business opportunity, particularly, by the way, as we start to get codes from potentially Medicare and potentially insurance starts to pay for these interventions, which may start sooner than later. There are going to be opportunities to scale this. So that means having, standardized dictionaries and standardized, metadata tags, and creating a platform that allows HIPAA compliant data transfer, including transfer with the electronic health record. So we have our own local solutions that we've sort of home built, so that, for example, our headset can even compose its own note. This is something that we're working on, so that when somebody receives virtual reality in the hospital, all the data about what they saw, how long they saw it, we even can collect data in the headset on their pain and anxiety scores before versus after the treatment. And all of that data can be composed into a note that is put into the electronic health record. But we have our own kind of local systems for that. We need to be able to scale that and have ways for health systems across the world to use a similar platform. So there's really incredible opportunities here. And some folks I've heard have been working on it. I think in Europe in particular, there's a company working on this, but I still need to see, a large scale opportunity kind of realize itself.
Actually, the Extended Reality Safety Initiative has been developing its own privacy and safety framework, which includes a lot of these features, I guess you could say, of data labeling and standardization in order to make this data more interoperable. And some of us are working outside with larger developer communities to also see if we can enable that to happen. Have you thought anything about, like, say, some of the computing power that may be available? Because these headsets are essentially smart devices at the edge. And we could maybe deploy some maybe machine learning at the edge also to make sense of data, potentially even in real time.
Yeah, for sure. So we are starting to think about some of the machine learning and AI capabilities and opportunities here clinically. So, for example, measuring biodata, like I showed you in that example there. There are all sorts of signals in that noise. Can even use EEGs to get to sort of your end of the woods here, to measure brain signals and get a sense of the physiologic and even neuropsychological responses of an individual, and then use those data potentially to modify the experience in real time and tailor the experience to that individual's needs. So these are all interesting opportunities. We also are using peripherals. For example, I'm a gastroenterologist, so I'm particularly interested in irritable bowel syndrome, and we're using VR for IBS. And we have a wearable sensor that I created years ago that's actually FDA cleared that measures intestinal activity. And that's yet another signal source that we could put into a headset to provide a biofeedback loop for people with IBS who are learning how to sort of modify their own motility or intestinal movement. Lots of different kinds of data that we need to protect, collect and protect, and that there are AI and machine learning opportunities to interpret.
Would you encourage any of today's sort of crop of medical students or residents coming up through training to perhaps get some experience in cyber health security and help make these systems possible?
Well, sure. I think those that have that orientation, there's really, as I said, interesting opportunities. And on top of all this, we'll be hearing from Apple pretty soon, as I think I mentioned. Their XR ecosystem will be coming out soon enough. And when that happens, when Apple gets involved, things change. And so there's going to be a lot of interest in healthcare applications of that ecosystem. So I think we need more clinicians, whether they're physicians or nurses or any type of clinician for that matter, who understand the patient perception, understand their knowledge, attitudes, beliefs, preferences, and their conditions, and understand, computer programming and computer science. So we're very fortunate to have Omer Liran, who I showed you in my talk, who is both a practicing psychiatrist and a full stack developer programmer, who actually creates all of our software, understanding from the ground up what the patient needs are and what the the HIPAA requirements are. So those folks are pretty few and far between, and we need more of them.
With that, Dr. Spiegel, I'd really like to thank you for your time. It's been pretty eye-opening, and I think that the best part of your presentation was actually seeing some of those patient stories, because they really were moving. They were so emotional.
Yeah, that's it. I mean, that's why we do this work. Thank you.
Thank you.
You think about some of the machine learning and AI capabilities and opportunities here clinically. So, for example, measuring biodata, like I showed you in that example there. There are all sorts of signals in that noise. Can even use EEGs to get to sort of your end of the woods here, to measure brain signals and logic and even neuropsychological responses of an individual, and then use those data potentially to modify the experience in real time and tailor the experience to that individual's needs. So these are all interesting opportunities. We also are using peripherals. For example, I'm a gastroenterologist, so I'm particularly interested in irritable bowel syndrome, and we're using VR for IBS, and we have a wearable sensor that measures intestinal activity. And that's yet another signal source that we could put into a headset to provide a biofeedback loop for people with IBS who are learning how to sort of modify their own motility or intestinal movement. Lots of different kinds of data that we need to protect, collect and protect, and that there are AI and machine learning opportunities to interpret.
Would you encourage any crop of medical students or residents coming up through training to perhaps get some experience in cyber health security and help make these systems possible?
Well, sure. I think those that have that orientation, there's really, as I said, interesting opportunities. And on top of all this, we'll be hearing from Apple pretty soon, as I think I mentioned, their XR ecosystem. When that happens, when Apple gets involved, things change. And so there's going to be a lot of interest in healthcare applications of that ecosystem. So I think we need more clinicians, whether they're physicians or nurses or any type of clinician for that matter, who understand the patient perception, understand their knowledge, attitudes, beliefs, preferences, and their conditions, and understand science. So we're very fortunate to have Omer Liran, who I showed you in my talk, who is both a practicing psychiatrist and a full stack developer programmer who actually creates all of our software, understanding from the ground up what the patient needs are and what the HIPAA requirements are. So those folks are pretty few and far between, and we need more of them.
With that, Dr. Spiegel, I'd really like to thank you for your time. It's been pretty eye-opening, and I think that the patient stories, because they really were moving, they were so emotional.
Yeah, that's it. I mean, that's why we do this work. Thank you.
Thank you.